Hey guys, all right. So this is example 4 from 11-2. Solve each system of equations using matrices. So that means you have to use matrices, okay? No ifs, ands, or buts about this. If the system has no solution, say it is inconsistent. So we have A and B. Obviously, A looks a lot easier and B looks a lot scarier. So just kind of organize, just that way I'm not like crazy messy. I'm going to divide this up. As you can see, B will require lots and lots of space. So let's do A first. To solve using matrices, you want to, step number 1, write it as an augmented matrix. So we have 3 equals to 3, 4, 2 equals to 8 or 3. Step number 2, you want to reduce this into row echelon form. So row echelon form. That means the diagonal's got to be 1s, and then below it, it has to be 0. So the first thing, for this particular example, I'm going to change one row at a time. So this one, I will change row 1. To get 3 to become a 1, I'm going to multiply the entire row by 1/3. If you change one entry in the row, you got to change all of the entries. So this is now 1, 1, and it happens to be 1. Row 2, I did not change it this time, so I would just copy it straight up. Now step number 3, remember, keep on going until all of the diagonals are 1, and below that will be 0. Step 3, we are now going to try to get the 4 into a 0. Now to do that, I'm going to change row number 2. To get that to be a 0, you want to multiply its -4, whatever the number is, you want to multiply its opposite, to the row above it that contains a 1. So in this case, there's only 2 rows. So the row above it is a row 1. And then you want to add itself. So that is now row 2. So this is going to give us, again, this particular operation, I'm only changing row 2. So I don't need to do anything to row number 1. So here we go. -4 times 1 is going to be -4. -4 plus row 2, which is 4, is 0. So that's why it works. -4 times 1 is -4 plus 2 is going to be -2. -4 times 1 is -4 plus 8 over 3 will give us a -4 over 3. Almost there. We now just have to change this into a 1. So that's changing row 2 again. And to get that into a 1, I'm going to multiply its reciprocal. Well, what do you change to 1 entry? You have, row 2. You have to change it to all of your entries. So row 1 again remains unchanged. So 1, 1 equals to 1. 0 times a -½ is going to be 0. -2 times a -½ is a 1. -4/3 times a -½ is a positive. And that will give us a positive 2 over 3. As you know, this is x, this is y, and then equals to a constant. So right away, look, you have a y equals to 2/3. Bam, you're done with y. This can be rewritten as y plus x plus y equals 1. If you know y is 2/3, we can definitely solve. This will become x plus 2/3 equals 1. I mean x equals to 1/3. You have y right away. We solve for x, so we write it as an ordered pair. 1/3, comma, 2/3, and box that up. So that's how we solve using matrices. And that question is a lot easier than for B. For B, we will follow the same format, except that it looks a lot scarier, okay? So similarly, we are going to write it as an augmented matrix. So that means I'm gonna need a big one, because this one looks ginormous. 1, 1, 1, 1 equals 4, -1, 2, 1, no w, so 0 equals 0. 2 3, 1, negative 1 equals to 6, negative 2, 1, negative 2, 2 equals to negative 1. So that's the augmented matrix. Now let's try to get the diagonals to 0. Whoa, that one's already, I'm sorry, diagonals into 1. That one's already 1, so now I just have to work with the bottoms and turn them into 0. And now, because you should be, if you're used to it, we can do multiple steps at the same time. So this is step number 2. Step number 2, I will change row 2. I will change row 3, and I will change row 4. I will try to get all those values under the first entry to become 0. To do so, I'll start with row 4. Remember, I want to get the negative 2 in row 4 to become a 0. So we will multiply its opposite, which is 2. Multiply this right here, because that's the only one with the 1. So multiply row 1, and then add itself. Same thing with row 3. Row 3, we're trying to get 2 to become a 0, so its opposite would be negative 2 times row 1 plus itself. Same thing with row number 2. Multiply its opposite, which is 1. 1 times R1 plus R2. But remember, 1 times anything, it's itself. So this particular step, you can even think of it as just adding row 1 and row 2. So that's our next matrix. Okay, since I am not changing row 1, I'm going to copy row 1 over. All right, let's do row 2. Ready? I have to really be careful, and I'm going to check after each and every row once I'm done doing the basic math, so I don't make silly mistakes. Row 2 is adding this together, so that will give us 0. This will give us 3. This will give us 2. This will give us 1, and this will give us 4. Let me just really do a quick glance to make sure I'm good and I look good. All right, let me erase the circle so you're not confused on my next operation. Row 3, I'm going to take negative 2 times row 1. So row 1 is 1, so negative 2 times 1 plus row 3. So row negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 times 1 is negative 2 plus 3 is 1. Negative 2 times 1 is negative 2 plus 1 is negative 1. Negative 2 times 1 is negative 2 plus a negative 1 is negative 3. Negative 2 times 4 is negative 8. Negative 8 plus 6 is negative 2. Let me just double check to make sure my basic math looks okay. It does look okay. Next, again, I'm going to erase. I'm only doing this boxing and circling so you know what I am looking at, okay? Blue, okay. Next, I'm changing row 4. 2 times row 1, which is 2. 2 plus negative 2 is 0. 2 times 1 is going to be 2. 2 plus 1 is 3. 2 times 1 is 2. 2 plus negative 2 is 0. 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. 8 plus negative 1 is going to be 7. So let me double check with that. 0, 3, 0, 4, 7. Good. So step number 2 is done. I have accomplished the ones and the zeros for my column number 1. Step number 3, I would like for the remaining, remember these all have to be ones. So what you want to do is look around in column 2 to see if you can switch any of the row 2, row 3, and row 4. And in this case, you can because these, okay, can be switched. And when I say switch, you have to switch the entire row. So switch row 3 and row 4. So we are going to write row 1 over 1, 1, 1, 1 equals 4, 0. Did I say row 3 and row 4? I'm sorry, row 3 and row 2. Okay, 0, 3, 0, 4, 7. So row 3 is now row 2. So 0, 1, -1, -3, -2, and row 3 is now row 2. So row 2 is now row 3. So 0, 3, 2, 1, 4. Let me just quickly glance at it to make sure I copy down everything correctly from the previous matrix, because if I don't, I have to go back, and as you can see, it's a lot of writing. Next step, number 4. Make sure these guys right here are now zeros. So to turn those into zeros, they're not too bad. So we are going to change row 3 and we are going to change row 4. And to change it to zeros, again, you take its opposite. You multiply the row above it that contains a 1. So in this case, row 2, and then you add itself. Same thing with both, because they looks like they both have 3. So multiply the row above it that has a 1, which is row 2, and then add itself. All right, and let's do it. I'm not changing row 1 and row 2, so I'm just going to copy those guys over. Equals to 4, 0, 1, -1, -3, and -2. Okay, so here we go. If these guys were zeros before, they will most likely be zeros unless you made an error. Okay, so once you do the computation, this is going to be 0 here and 0 here. Okay, and then row 3, I'm going to have 0, 0, 5, 10, and 10 with my row 3 changes. Row 4, I will have 3, 13, and 13. Next, I would like to get this guy right here to become a 1. So that's my 5th matrix. So I'm changing row number 3. To get that into a 1, I will multiply all the row 3 by 1/5. So that means row 1 is not changing. Row 2 is not changing. Row 4 is not changing. Then all of these values are now 1/5 its original. Matrix number 6, I now would like to get this guy to become a 0. So I'm changing row 4. That means I want to take its opposite, multiply the row above it that has a 1, which is row 3, and add itself, which is row 4. That means I'm not changing row 1, so let's copy that over. I'm not changing row 2. And copying, it's a difficult task, because if you or I make any mistakes on these, then I got to go back and do it all over. So here we go, 0 times, this is 0. And once you do the computational, you're going to end up with, it used to be 3, 13, 13. You're going to end up with a 0, 7, and 7. So now we just have to get this guy to become a 1. So that's my matrix number 7. We are going to change row 4. To get that a 1, we multiply by 1/7 to the original entry of row 4. That means the first 3 rows did not get changed. 4, 0, 1, -1, -3, -2, 0, 0, 1, 2, and 2, 0, 0, 0, 0, I'm sorry, not 0, 1. 1/7 times 7 is 1, and then 1. Okay. So here's where we are at. Now, remember, we have x, y, z, and w. So the first equation you're going to have is w equals 1. Yay, you solved for it. Then next, you have no x, no y, and I'm going from bottom up. We have 1z plus 2w equals to 2. Well, if that's the case, if you know what w is, this will allow you to solve for z. Z plus 2 times 1 equals 2. That means Z is going to be 0. Yay! You got 2 answers. Now the next equation is no x, but you have 1y minus a z minus 3w equals -2. Well, you know w, you know z, so now you can solve for y. Z is 0. Okay, well, w is 1. So when we add 3 to both sides, y would turn out to be 1. Whoop! Almost done. Now this last one, you have an x, a y, a z, and a w, and it equals to 4. Well, x is not known. We're trying to solve for that. Y is 1. Z is 0. W is also 1 equals to 4. If you solve for it, x comes out to be 2. So you have your answers, right? Oops, that's not big enough. We want to put x, comma, y, comma, z, comma, w. And we have all 4 values. X is 2, y is 1, z is 0, and w is 1. And that is one answer. It is consistent. Consistent means you have an answer. And that is the end of example 4.